Hello and welcome to yet another installment of the pre-calculus videos, and this is a section over domain and range. And what we want to do is we want to determine the domain and range of a function in both mathematical and real-world contexts. So, let's just kind of talk about it. What is domain, what is range? And so domain, I automatically, whenever I think of domain, I just think of x values. Okay, those are x values. And then range, y values. Okay? And the question that you kind of are asked is, where are these values? Okay, so where are x and y values on a graph? Okay, and that's the question you ask yourself. Okay, so you can go through all this stuff, and it says it is the set of all the first coordinates in a relation. Those are x values. Okay, it is a set of outputs corresponding to the domain values. So these are the y values. So, all this crap, all right? But just realize domain means x values, range means y values. So let's take a look over here, and let's talk about this graph that we see. And it says, the domain goes from -2 to 4. And so what I like to do is I like to kind of highlight and sit there and go, okay, where do my x values start? Okay, and where do they end? And they start at -2. Okay, and I know that my x values go all the way up until I get to 4. They don't exactly get to 4, but that's the idea. So, you think about it. Where do you start? Okay, where do you start? Okay, where do you end? And you go from left to right. And we start at -2. Okay, and we include -2 because there's an actual point there, but we don't include 4 because there's an open hole at 4, okay? And you could even put this is an inequality notation. If you wanted to say your domain, you could also say that you go from bracket -2, comma 4, parenthesis, okay? And then the other thing, okay, is range, okay? So where do you start and where do you end? And so, so then what I do, let me highlight this, and I'm going to go, well, we start at what looks like 1, okay, and then we go all the way up to 5, but we don't include 5. So I kind of come in here and draw this little picture like this. And so, where do you start? Where do you end? Okay, on 5. Okay, so or for y values. So you start at 1, and where do you end? And that's at 5. But because we have an open circle, we don't include that. So that's why you have 1 is less than or equal to y is less than 5. Okay, and so the range, we wanted to show the range, then we would say, in interval notation, we would say bracket 1, comma 5, and don't include that. Okay, so that's the idea. We'll look at a bunch of these, and I'll kind of keep doing the same thing and asking the same question. So let's move on to the next page. Okay, so let's take a look at these next two questions, and what we want to do is we want to just be, given a graph, figure out the domain and figure out the range. And so I will do this both in interval notation and inequality notation so that we kind of understand. But let's just take a look at this first one, and we have the line y equals x, or f of x is equal to x. So that's a straight line with a slope of 1, y-intercept is 0. And so the question is, where do I have my x values? Okay, and what we can say here, the domain is that this is all real numbers. Okay, all real numbers, meaning that we can have negative x values, 0, and positive x values. Okay, and the same thing with the range. Where do I have y values? Okay, do I have negative y values? Do I have 0 as a y value? Do I have positive y values? And the answer to that question is yes. So this is all real numbers. Okay, if I wanted to put this in an interval notation, I would say that this goes from -infinity to +infinity. Okay, same thing with the range. This goes from -infinity to +infinity, okay? Now, let's take a look at the next one. The next one, we have this horizontal line, f of x is equal to 2. So same thing as like saying y equals 2. And, where do we have x values? Do I have negative x values? Do I have 0 and a positive y values? And the answer to that is yes. So the domain would be all real numbers, okay? And actually, that's going to be true for all polynomials. And let's write that over here. All polynomials have a domain of all real numbers. Okay. And that includes like lines, parabolas, cubic functions, so any polynomial. So all polynomials have that same value. Okay, so but then the range, you know, and this is where it gets tricky. It says, okay, where do I have y values? Okay, do I have negative y values? And the answer to that question is no, okay? Do I have 0 as a y value? The answer to that question is also no, but do I have any positive y values? And the only y value that we have is 2. So the range here is just going to be y is equal to 2. And that's it, okay? All right, so now let's come over here and let's say, it says that the function c is equal to 2.5m represents the cost of a taxi ride of m miles, okay? So your x-axis is miles, your y-axis is cost. And it says, what is the domain and range? So the question is, you know, can you have 0 miles? If you just get in the cab and you don't go anywhere, how much are they going to charge you? And the answer to that is $3, okay? But the other question is can I have negative miles, okay? And the answer to that question is no. So the domain on this would be that x, or m rather, because that's our independent variable, m is greater than or equal to 0, okay? And then we also know that our range, okay, where do we start? Where do our y values start and where do they go up? And that's going to be the value c is greater than or equal to 3. Okay, so the cost of this is going to be larger than $3, but in order to do that, you have to travel 0 miles or greater to get to that point. So, you know, if you want to put this in interval notation, or I'm sorry, in inequality notation, you do it like this. But if you wanted to put it in interval notation, then you would say that you start at 0 and you go to positive infinity. Okay, theoretically, all right, you're not going to go infinity miles in a cab, then you would just rack up a serious cab bill. No, you wouldn't be happy about that, but I digress. Okay, if we're talking about range in interval notation, where do we start? We start at 3, and we go up from there to positive infinity. Okay, and that's what we're doing. Okay, that's that. Okay, next one. Let's take a look at a cubic function. And remember what I said about a polynomial. This is a polynomial. Okay, x cubed is a polynomial. And it says, what is the domain? The domain is all real numbers. So all real numbers. Okay, I can plug in negative x values. I can plug in 0. I can plug in positive x values. And if I wanted to put that in interval notation, I would say this goes from negative infinity to positive infinity. Okay, and then what's the range? All right, so you know, where do you have y values? Do you have negative y values? And it's going to continue to go this way. They're going to get more and more negative. Okay, what about 0? Okay, we got that, and we have positive values. So the range, same thing here. It's all real numbers. Okay, and we would say that goes from negative infinity to positive infinity. Okay, now something like this, where you have x to the 4th power, this is still a polynomial. Okay, so the domain, like I said, you know, I can plug in positive x values, I can plug in 0, and I can plug in negative y values. So my domain is all real numbers, okay, which we would also say goes from negative infinity to positive infinity. Okay, and then the range would be going from 0. Okay, we don't have any negative y values, but we start at 0, and we have positive y values from there. So the range would be the y values, y is greater than or equal to 0. Okay, and if you wanted to put that in interval notation, you would say that 0, comma, positive infinity, and you go in that direction. Okay, so that's it. All right, now on something like this, what's the domain and range of a absolute value equation? Okay, so the domain, you know, on something like this, where do you have x values? Okay, I've got negative x values, I've got 0, and I've got positive y values. So the domain goes from negative infinity to positive infinity, okay, which is all real numbers. All real numbers. Okay, but what about the y values? What about the range? Okay, and if we wanted to talk about the range, we see that we don't have negative y values, we have 0, and then we have positive y values. So what we would say is that our range, okay, goes, you know, we know that the y values are greater than or equal to 0, okay? Or you could say it like this. You could say y is greater than or equal to 0, okay? Whichever one you want to say, it doesn't matter. They mean the same thing. Okay, or you can put it in interval notation and say that your values include 0 and we go to positive infinity, okay? All right, that's it for that page. Let's move on to the next one. Okay, let's take a look at this next page. And what we have here is we have, and let's call this up here, I'm going to say domain of a radical function. Okay, and let's just graph, f of x is equal to the square root of x. Okay, that graph looks like this, where we include 0 and we have this, like what we call like an eyebrow. Okay, now the reason why, and we kind of have to think about this for a second. What is a square root? A square root means two numbers that multiply to that number. So, if we get, say square root of 4, two numbers that are multiplied by itself to give me 4 is going to be 2. Okay, same thing with the square root of 9, which is going to give me 3. But what about this? What if we did the square root of -1? Okay, that's a problem because there are no two numbers that multiply, that are the same, that multiply to -1. Okay, so this number, this x value must be positive. Okay, you can't have a negative number underneath your radical. Okay, the only numbers that multiply to -1 would be -1 and 1. Okay, and so because those aren't the same numbers, this doesn't work. So this doesn't work. Okay, we'll talk all about the square root of -1, but that doesn't work. Okay, so they must be positive. So when we think about that, what we want to do is we want to set up an inequality to solve and figure out and find the domain. So what I know is that, this part right here, 2x plus 4, this must be positive. Okay, so because that has to be positive, what we say to figure out our domain is we say that 2x plus 4 is greater than or equal to 0. And then what we do is we just solve for x. So we subtract 4 from both sides, and we get that 2x is greater than or equal to -4. We divide by 2, so we get that x is greater than or equal to -2. Okay, and what that means is that, this is the domain, okay, this is the domain D, but if we wanted to put that in interval notation, we would say that, we could start at -2 and go to the right, and we get from -2 to positive infinity, okay? Now, let's do the same thing down here, except for now they want the range, okay? Now, we have to do some transformations on this. We'll learn more about transformations in the next unit. But if I have this graph, okay, what I know is that, this value here, 5 minus x, okay, must be greater than or equal to 0. And what I'll just go ahead and do is just add my x to the other side. And I get that 5 is greater than or equal to x, okay? And really what this means is that x is less than or equal to 5. So that's our domain, x is less than or equal to 5. And then if we wanted to put that in interval notation, we would say this goes from -infinity to 5, okay? Bracket here, parenthesis here. Now for the range, let's just go ahead and just graph this function. So I'm going to graph it real quick and put that picture up. Give me a second. And so once we get this picture up here and show that graph of that function, okay, the domain we got right. We know that the x values are going to be less than or equal to -5 or to 5. So here are those values here, and the graph goes to the left. Okay, so we start from -infinity, we go all the way up to 5, and then we stop. Okay, and that's it. The range is a little bit different. Where do we start on the bottom and go up? And what we see is that the range is all the values that are less than or equal to -3. So the y values are less than or equal to -3. And that -3, that's where that comes in. Okay, so that shifts the ground up or down. And then, but we had to, realize that because this radical is negative, okay, it flips the graph and it has it going down this way. Okay, so that y is less than or equal to -3, and then we have, we can say that goes from -infinity, comma, -3, put brackets and a parenthesis. Okay. All right, let's take a look at something like this. This is an exponential function, and what we know about this exponential function is that we have this graph here, y equals 1/2 x plus 2. Okay. So the domain for an exponential function goes from -infinity to positive infinity. It's all real numbers, okay, all real numbers. But then the range, okay, is a little bit different. The range, and because of this plus 2, all right, shifts the graph up 2. And what we get is we get this. We get that y is greater than 2. Now, we don't include 2 because there's actually an asymptote at 2 that this graph doesn't touch, okay? And we found that out from the exponential unit when we did it back in the first quarter. But if I wanted to put this into interval notation, I would say that this goes from 2 to positive infinity. But we don't include the 2, and that's because we have an asymptote, okay? So this graph will never actually have a value of 2, a y value of 2, but it will be strictly greater than 2, okay? So that's an exponential. Now let's look at a log. Okay, now a log, remember, is the inverse of an exponential. So the domain, that part is, switched with the range, all right? So what we get is we have this vertical asymptote at -2, okay? So what we can say here, and I get that from here, so whatever goes inside of a log, this must be positive, okay? Same thing with the radical functions, okay? So when I take x plus 2, I'm just going to set that greater than 0. And then I subtract 2 from both sides, and I get that x is greater than -2. Okay, and that's my domain, all right? But I could also put that in interval notation and say that this is, we have parentheses, we include the -2, and then that goes to positive infinity, okay? Now, the other thing we can say we need to talk about is the range. Now, with a log function, the range is going to be all real numbers, okay? I'm going to get negative numbers this way, and I'm going to get positive numbers this way. So this is always going to be all real numbers. Okay, this goes from negative infinity to positive infinity, all right? And that's that. So it's kind of, logs and exponential functions are kind of the opposite. Okay, your domain in an exponential function is always going to be negative infinity to positive infinity. The range in a log function is going to be negative infinity to positive infinity, okay? So that's what we're dealing with. All right, now let's talk about vertical and horizontal asymptotes. I want to go over this. This isn't in the Edgenuity video, but let's talk here real quick. Vertical asymptotes. So vertical asymptotes, okay, and I'm going to call them VAs, okay, that's my acronym for it. This is when the denominator of a rational function, so the denominator is 0, okay? Those give you vertical asymptotes, okay? Now, horizontal asymptotes are a little bit different, okay? So horizontal asymptotes, I'm going to call those HA. That's when, so let's talk for a minute. So in a rational function, if the degree in your numerator is small, divided by the degree in your denominator is big, then that leads you to having a horizontal asymptote at the line y equals 0, so the x-axis, okay? Okay, that's the first option, okay? The second option is, with a horizontal asymptote, is if your degree in your numerator is the same as the degree in your denominator, okay, then your horizontal asymptote, okay, then this leads you to having a horizontal asymptote is the line of the ratio of leading coefficients, okay? So the line of a ratio of leading coefficients, all right? And we'll talk all about this, but I just want to make sure, we just want to get it down. The last one is when you have a degree that is big in your numerator divided by a degree that is small, okay, then you have no horizontal asymptote, okay? You actually get what's called a slant asymptote, but we'll talk about that later, okay? So I just want to make sure you have that written down, and we'll go from there. Let's look at some graphs of rational functions. Okay, so let's take a look at these, and let's do this one first. And so what I end up getting here is I want you to take a look at something first. Okay, let's look at our horizontal asymptote. Okay, and what I want to look at is the degree. Now remember, the degree is the largest exponent. So what I have here is I have a degree of 1 divided by a degree of 1. Okay, I'm strictly just looking at the exponents. Because these are the same, okay, I'm looking for the ratio of leading coefficients. So what I have here is I have a horizontal asymptote at the line y equals 1. Okay, because I have a coefficient of 1 divided by a coefficient of 1. So that's my horizontal asymptote. Okay, now let's talk about a vertical asymptote. Okay, a vertical asymptote is when your denominator is 0. So what I do is I take my denominator, which is x plus 2, I set that equal to 0, and I get that x is equal to negative 2. Now, this is the value, okay, this is the value that makes my function undefined, okay, makes my function undefined. So therefore, because that makes it undefined, that's not going to be a part of my domain, okay? So I find these asymptotes so that I can, tell what my domain and range is. So my domain, what we notice is that I can plug in any number, okay, that's negative, that's less than negative 2, and any number that is larger than negative 2, okay, and I can have that as a domain. The only value that I cannot plug into this function is negative 2. So my domain is this. My domain goes from negative infinity to negative 2, and then we union that with from negative 2 to infinity. That's an interval notation, okay? We could say all reals except when x equals negative 2. Okay, that would be our domain. Okay, now our range, we have to use the horizontal asymptote. All right, so the only value that doesn't work, that's not going to have a value, is 1. Okay, so I have a domain here. You know, this vertical asymptote is here. Okay, that's my vertical asymptote. My horizontal asymptote is here. Okay, this is the line x equals negative 2. This is the line y equals 1, okay? So my range, and let's come up here, my range goes from negative infinity to 1, and then I union that with from 1 to positive infinity. Or you can say all real numbers, except when when y equals 1. Okay, that's the only value that isn't going to work, okay? So that's what we're doing. Okay, now let's take a look over here. And what I get on this one is, first thing I'm going to do is my horizontal asymptote. Okay, so I have a horizontal asymptote, and my degree in my numerator is 2. Okay, I'm just looking at my exponent divided by the degree in my denominator, which is also 2. Okay, so these are the same. So I have a horizontal asymptote at the line y equals, and then I just look at the numbers. Okay, I have 2 divided by 1, so this is the line y equals 2. So I have a horizontal line at y equals 2. Okay, and that's my horizontal asymptote. Okay, the other thing that I have is we end up having this thing down here, okay, my denominator. So let's look at our vertical asymptotes. So if I set x squared minus 4 equal to 0, okay, I can solve this for x, and I can add 4 to both sides, and I get that x squared is equal to positive 4. If I take the square root of those, then I get that x is equal to plus or minus 2. Okay, so I get these vertical asymptotes at positive and negative 2. Okay, this is x equals 2, this is x equals negative 2. All right, so as long as I find those, then I can figure it all out. So let's first find our domain. Our domain goes from negative infinity to negative 2. We union that with from negative 2 to 2, and then we union that with from 2 to infinity. Okay, so we could also say all reals except x cannot equal plus or minus 2. Okay, now let's talk about our range. Okay, our range is very similar, but our range goes from negative infinity to positive 2, okay? And then from 2, let me do this, union that with from 2 to infinity. Okay, we can say that this is all real numbers except y equals 2, okay, or y cannot equal 2, okay? So that's it, all right, and that's what we're doing. So let's take a look. Now, if you're just given the function, it says choose the function that has a domain where you can't have a negative 1 and your range is y, okay? So here's what I want to do. For my domain, okay, given a rational function, okay, if I plug in negative 1 into any of these functions, which one that makes my denominator 0? And it's this one right here, okay? If I found f of negative 1, then I get 2 times negative 1 plus 1 over negative 1 plus 1. This becomes something over 0, which is undefined. Okay, now the range is that y cannot equal 2. So I'm looking for a horizontal asymptote of y equals 2. And so I'm looking here, I see I have a degree of 1 over 1. These are the degrees are the same. So the leading coefficients would just be 2 over 1, which is just 2. Okay, so the range you couldn't have 2. All right? Okay, now take a look at a piecewise function. This will be the last one. This will be the last one. So what we have here is we have this thing here where we have the function of 0, okay, between 0 and 1. We have the function of 1 from 1 to 2, and then we have the function 2 from 2 to 3, okay? So if I wanted to find the domain here, okay, then I'm just going to, write out my domain, okay? And I know that I start at 0, okay? So I know that I have x values. I start here at 0, and then I go all the way from 0 to 1. Okay, even though I jump up here, I have values from 1 to 2, and then even though I have a hole here and jump up here, I have values from 2 to 3. So really what I have is that my domain starts at 0, and we go all the way to 3, but we don't include 3. Okay, so we would say that 0 is less than or equal to x, which is less than 3. Okay, so you can do either or of these. This is interval notation. This is inequality notation. Our range, though, is a little bit different. Okay, we only have the y values of 0, 1, and 2. So my range, I have y equals 0, 1, and 2, and that's it. Okay, there's no interval notation here because I can't really model that, but that's it. Okay, so I hopefully it's a review for you. This part might be the part where it might kind of screw you guys up, but we'll just go from there. So I hope you enjoyed the video, and we'll talk to you later. See ya. Bye.